Hi there, here is my combo lesson that I taught today being Tuesday, October 29th. So, we're going to start with some just real basic definitions, some key vocabulary terms. So let's get started. Standard form is AX plus BY is equal to C. Slope-intercept form is Y is equal to MX plus B. What we're going to do today is make the connection between these two. They are definitely connected. Even though you don't see an A, you do see a B, but it's not the same B, and you don't see a C. But we do see other things that are the same. This X and Y. So I want you to always remember that an X and Y is an ordered pair. That I can use X and Y as an ordered pair and plug it in or substitute it into these equations to find values that I need. The other thing that I want to point out is the standard form is great for finding intercepts. So when I talk about intercepts, I'm talking about the 2 points when X can be 0 and I have a Y value, or when I have an X value and I know that Y is 0. This is the way I note intercepts. And I really like to use this standard form to be able to find intercepts. The slope-intercept form is really helpful as well because I've got some really key pieces of information. I know that M is my slope, which is also my rate of change. We'll define it more below in my table. We also know that B is the y-intercept. That's a really important piece of information as well because notice up here, I can get an intercept, I can get my y-intercept. So that is when X is 0 and I have a value of Y. Okay, so now let's go ahead and do some definitions down here. We know that slope is the rate of change. We've seen it before. When I talk about the rate of change, I'm talking about the change in Y over the change in X. I also note that I can write it this way, delta Y over delta X, delta meaning change in, and I can take it one step farther and say that if I have two ordered pairs of X1, comma Y1 and X2, Y2, that I could actually find the change in these values by subtracting Y2 from Y1 and taking X2 minus X1. That's taking the difference, which is the change. And this is going to give me my slope. And everybody knows that slope is the letter M in this equation, y is equal to mx plus b. So there's something else about slope that I want to point out. I'm going to draw a quick coordinate plane right here. This is x and y. That I could have a positive slope. That means when I read my graph from left to right, my line's going up. And if I read my graph from left to right, this slope is going down. It's negative. So it's decreasing here and increasing here. So I have a decrease in the rate of change, or I have an increase in the rate of change. Typically my rate of change is usually over time, but it can be over anything. Okay, so let's go on and define a y-intercept. I'm going to first draw a coordinate plane, and I'm going to note that the y-intercept is where my line right here crosses the y-axis. So at this point right here, I know that x is 0, and I have a value of y. So this is where this point, this is called the y-intercept. I could do the same thing for an x-intercept by drawing a coordinate plane again, quickly, labeling, this time drawing another line, and noting that right there, that's where my line is crossing. This is the x-intercept. My line is crossing the x-axis, and I know there that I have a value of x, and my y is 0. Okay, so that is some really brief definitions with some pictures. Moving on to the second page. In the second page, what we're going to be doing is we're going to be looking at standard form and slope-intercept. And I've got a situation up here where I've got an athlete that wishes to burn 700 calories a day, and he wants to burn these 700 calories a day by running and swimming. We're told that he burns 17.5 calories per minute of running, and he burns 12.5 calories every time he runs or swims freestyle swimming. So that's a rate, 17.5 calories per minute of running, 12.5 calories per minute of swimming. How many calories does he want to burn in total? He wants to burn 700 calories. We're given that x is going to represent the number of minutes of running, and y represents the number of minutes of swimming. So to represent the combination of running and swimming that he could do in order to burn 700 calories, we could write the following equation. We can write 17.5x plus 12.5y is equal to 700. So what does the x stand for? Well, the x stands for the number of minutes that he needs to run. And what does the y stand for? The y stands for the number of minutes he needs to swim. Okay, and if I just go down and ask you, like, what is the form of this equation that we just wrote? Well, it's standard. It's a standard form. How do I know it's the standard form? It follows the format of ax plus by equals c. So take a look. Here's my a, here's my x, here's my b, here's my y, and it's equal to c. C is some constant, or in this case, it's the total. So if I think about it, we can reason that the more minutes he runs, so as his running time increases, well, his swim time is going to decrease. The minutes that he swims is going to decrease because he has only 700 as his goal. So, in other words, as x increases, y decreases. So I can draw a quick little sketch here. And as x increases, so as x gets bigger this way, what happens to y? It gets smaller. So, if I start here and I go down here, my y value is getting smaller, so y is smaller. And what's going on here? X is increasing. Okay, so we've got some questions that I want to answer as a result of this problem. The question is, if the athlete only runs and he doesn't swim. So let's go back up here. We know that x is the number of minutes of running. So running is x and doesn't swim is y. Okay? So if he only runs, so we're right here. If he only does this and he never does this, how many minutes would he need to run? Okay, so let's think about it. If I'm right here and he's only running Well, what do I know about the value of y? That y is equal to 0. Well, if y is equal to 0, can I solve for x? Absolutely. So if I know that y is 0 right here in this equation right there, I can definitely solve for x. So let's go ahead and do that. I got 17.5x plus 12.5y is equal to 700. Okay, now remember, I'm going to make y 0. So in other words, I'm going to take 12.5 and multiply it by 0. Well, this is 0 equals 700, and I've got 17.5x. Well, I'm adding 0, so this don't need that. So remember, a legal move tells me that in order for me to solve for x, I'm going to divide both sides by 17.5. And when I do that, I get the value of x, and the value of x is 40. Well, 40 what? Well, remember, I want to know 40 minutes. Remember that the x stands for minutes of running. So what this means is I am going to run for 40 minutes if I never swim. Or this athlete never swims, right? That makes total sense. So on a graph, and think about it, what's my ordered pair here? My ordered pair is 40, 0. How do we know that? Well, I made y 0 and x, so there it is right there. So y is 0, x is 40, so that is most definitely the x-intercept. Okay, so now there's another question we have to answer. And that question is, well, wait a minute, what happens if the athlete only swims and never runs? Okay, so now it's the reverse. So I want to know how many minutes would he need to swim if he only swims. So what do we know about x? We know that in this case, that x is going to be equal to 0. Well, I could do the exact same thing, use the exact same equation, because that's the equation I'm using. So I'm going to go 17.5x. I just rewrite everything so that way we know what we're talking about. 12.5y equals 700. Okay, and I'm going to say that x is 0. So 17.5 times 0 is 0 plus 12.5y. And remember, I want to solve for y. So in order to solve for y, I'm going to divide both sides by 12.5. And I get that y is equal to what? What is y equal to? If I divide everything out, 56 minutes. So what does that tell me? That tells me if he doesn't run. So no running. Therefore, I've got to swim for 56 minutes in order to burn 700 calories. Okay, so now take a look at this. We could graph and take a look here. 0, 56, right? So what do we know about 0, 56? Well, we know that x is 0 and y is 56. So what does that give me? That gives me the y-intercept. So take a look here. I've got no swimming. I'm sorry, no running. That's no running. And 56 minutes of swimming. And look down here. This means I've got to do 40 minutes of running and no swimming. Right there. So, and take a look here. Here's my intercept, my y-intercept. here's my x-intercept. And basically, any combination in here could be a combo, any combo of running and swimming. So I'll just show you what I mean. So if I want to do 8 minutes of running, that means that I can do about 47 minutes of swimming. If I don't want to swim that much, then if I want to do 8 minutes of swimming, then that means I'm going to have to do about 34 minutes of running. So this can help me if I was that athlete wanting to know how much I would need to swim or run and burn 700 calories. Okay, so I want you to remember that I'm in AX plus BY equals C. So now, what happens if I were to rearrange the equation and solve for Y? What would that tell us? Well, if I did that, and I'm going to rewrite the equation again, 17.5x plus 12.5y is equal to 700. Okay, so if I were to just solve for y, what would the equation look like? Well, let's do that. So in order to do that, I'm going to subtract 17.5x from both sides. And it's going to leave me with 12.5y is equal to 700 minus 17.5x. Okay, now in order for me to get just to 1y, I've got to divide everything by 12.5. These are all those legal moves, remember, that we did yesterday. So when I do all those legal moves, I know that I get 1y is equal to, and I'm going to take 700 divided by 12.5, I get 56 minus 1.4x. Well, gosh, take a look at that. I'm going to flip the page over. 56. That tells me something. Wait a minute. Right here, there's my y-intercept. So wait a minute. I just put this into y is equal to mx plus b. Well, but wait a minute, it doesn't look like mx plus b. Oh, but I can rearrange this. And look what I can write. Y is equal to negative 1.4x plus 56. So, what do I notice about the equation? What does this form tell us? Well, remember that my slope was negative 1.4x. That's according to this equation. And my y-intercept, according to this equation, is 56. But wait a minute, the y-intercept is an ordered pair, so I know that that's 0, 56, right? And, okay, but wait, this is kind of confusing to me. That's negative 1.4x. So they're saying that the slope is negative 1.4. Well, let's go back and look at this. Well, here's my negative. I totally get that. But where did I get negative 1.4? I got the negative. So let's do a little bit more investigating. So let's find the change in y over the change of x. Because remember we said delta y over delta x is the slope. So let's look at the change. So I'm going to go from 56 down to 0. So that changes 56. And now let's do the change in x. So I go from 0 to 40. That's 40. And, wow, that's a really big fraction, but I can simplify that. And I know that 4 goes into 40. That goes in 10 times. And if I use my calculator and put 4 into 56, I get 14, and remember it's negative. So I can keep simplifying that. Divide by 2, that's negative 7 over 5. Okay, well, wait a minute. 7 over 5, is that equal to negative 1.4? Well, again, I'm going to do a little bit more investigating here, right? So I'm going to remember that I can write that as 1 4/10. Because I could say it, 1 4/10. And I can simplify that to be 14 over 10. And I've got to remember that it's negative. Here we go. Right there. There it is. There's my slope. And I can simplify this down further to negative 7 over 5. Oh, so now I get it. I totally get that. This negative 1.4 is my slope. And my slope is negative 7 over 5. So this totally works. I could actually rewrite this to be y is equal to negative 7 over 5x plus 56. Or I could have left it like that. That's totally fine. Or I could have left it like that. Because this actually makes more sense to me. Because it means that my rate of change is 1 4/10. So that means I'm going to go down meaning negative, right? So down 7 for every 5. So that means every 7 minutes, let's just take a look at this. So every 7 minutes of swimming that I decide not to do, I can increase my minutes of running by 5. And I can scale that up or down depending, right? So that's how I figure that out. So that's pretty cool. So, but why did we go through all of this? Well, because I wanted to show you the relationship between standard form and slope-intercept form. That's why we did this. Is I didn't want you to just kind of do it in isolation. I want you to see that the standard form and slope-intercept form are equivalent. Yes, they are. And how do I know that they are? Well, in the previous, right here, it's the same graph. So, yes, how do we know? Same graph. Same solutions. Same intercepts. So, when do I use one over the other? Well, I'll be honest with you, I use whatever I need depending on the situation or what I'm being given. And I want you just to be comfortable using both. So the only other thing that we did is, well, we did this last activity, which was an activity having to do with graphing games and rides. And I did this equation right here. And I asked you to do on an exit ticket this equation right here. And basically what I wanted you to do is answer the questions based on the equation that you had been assigned. So, if I do the one of x plus y equals 20, that's standard form, and it's basically, I'm going to answer these questions. What's the number of rides the student could get on? Okay, so let's go back, and let's just make sure. I want to just clarify something. So what is x? X is the number of games. And what is y? Y is the number of rides. Okay, so let's go back here. X is games, right? and y is rides. And I know that if I have a combination of games and rides, I have $20 to spend. Okay, so now, if I just look at this, that means I've got one game, ride, $20. Okay, so what is the number of rides? So how many rides could I go on if I don't play any games at all? Well, that means that x is equal to 0. That's what it means. So take a look. If x is 0, how many rides could I go on? 20. Okay, and how about this one? What's the number of games a student could play if I don't go on any rides? So go back here. If I don't go on any of these, so that's 0, x can be equal to 20. Okay, so then it says, well, wait a minute. We're supposed to mark the point that represents the situation on both of these. Well, I got 20 and 20. Well, what's the value of y when x is 0? Oh, so when x is 0, number of rides is 20. If I don't play any games. Now, what happens if I play 20 games and no rides? There it is right there. So now I'm going to connect those as best I can. And I see this line going down. Why is the line going down? Well, let's think about it. Let's look at it this way. If I ride 20 rides and no games, what happens if I ride 18 rides? How many games can I play? 2. Oh, and 18 plus 2 is 20. What about if I play 16? If I go on 16 rides, that's 4. Oh, 16 and 4 is 20. So there's a relationship right there. So it's going down because as I increase the number of games that I want to play, my number of rides goes down because I only have $20 to spend. Okay, so if the student played no games, let's go back here. If I played no games, I can get on 20 rides. Totally understand that. Okay, for every additional game that the student plays, the number of rides, well, we just talked about it. As I play a number of games, what happens to the number of rides? It decreases. How much is it decreasing by? Well, from 20 to 18, that's 2. 18 to 16, that's 2. The number of games is 2. So 2 over 2 is 1. So it's only increasing by 1, which if I go back here, that makes complete sense because remember there's a coefficient of 1 in front of the x. So if I do one game, I could do 19 rides because I have $1 to spend for each. Okay, so now, if it's decreasing by 1, I can figure out the rate of change. We just did that. For 2 over 2 is equal to 1 over 1, and remember it's negative. Okay, so now take a look up here. Here's my y-intercept. I got it right there when x is 0. Y is 20. Okay, I get this. So I can rearrange the equation to solve for y. Well, what equation am I solving? Right up here, x plus y equals 20. X plus y equals 20. So I'll rearrange it to solve for y. Well, I'm just going to subtract x from both sides. And when I do that, I get y is equal to 20 minus x. Oh! Here's my 20. Minus x is my minus 1. So here's my equation right here. I can also write it as y is equal to minus x plus 20. Awesome. So that was today's lesson. It was connecting standard to y is equal to mx plus b. And how did we do it? We did it by looking at a variety of situations involving a graph, involving graphing intercepts, standard form, rewriting it into y is equal to mx plus b. So we totally got it. Hope you enjoyed this lesson. Please don't forget, exit ticket is due, and you can see me for that exit ticket if you weren't here today.